Rocket-initiated lightning strikes are a controlled method of triggering lightning by launching a rocket into a storm cloud. The rocket carries a conductive cable that trails behind it, creating a path for electrical current to travel. The process begins with the rocket launch. A rocket is launched vertically into the storm cloud, carrying a conductive cable attached to its tail. As the rocket ascends, the cable is deployed behind it, forming a conductive path between the rocket and the cloud. The rocket's ascent creates a strong electrical field between the positively charged cloud and the negatively charged ground. As the electrical field intensifies, the air between the cable and the cloud breaks down, creating a conductive channel. An electrical current then surges through the conductive channel, connecting the cloud to the ground. This results in a bright flash of lightning. Rocket-initiated lightning strikes are used for scientific research purposes, such as studying lightning formation and its impact on the atmosphere. They can also be employed for practical applications like triggering lightning safely to protect structures and aircraft from lightning damage. The conductive cable plays a critical role in initiating a lightning strike. It provides a preferred path for the electrical discharge, reducing the resistance and facilitating the flow of current. Without the cable, the electrical breakdown of the air would occur randomly and uncontrollably. The electrical charge buildup is another key factor. Storm clouds accumulate electrical charges through various processes, such as collisions between ice crystals and water droplets. These charges separate, creating a potential difference between the cloud and the ground. The rocket and cable effectively bridge this potential difference, triggering the lightning strike. The electrical breakdown occurs when the electrical field strength exceeds the dielectric strength of the air. The dielectric strength is the maximum electrical field that a material can withstand before it begins to conduct electricity. In the case of air, the dielectric strength is about 3 million volts per meter. When the electrical field between the cable and the cloud reaches this level, the air molecules become ionized, creating a conductive plasma channel. The lightning strike itself is a rapid discharge of electrical energy. The current can reach tens of thousands of amps, and the voltage can be millions of volts. The discharge heats the air to extremely high temperatures, creating the bright flash of light and the thunder that accompanies lightning. Rocket-initiated lightning strikes offer a valuable tool for studying lightning and its effects. They allow researchers to control the timing and location of lightning strikes, enabling them to make precise measurements of electrical currents, electromagnetic fields, and other parameters. This information can be used to improve our understanding of lightning and to develop better methods of protecting people and property from its hazards. In addition to scientific research, rocket-initiated lightning strikes have practical applications in lightning protection. They can be used to trigger lightning strikes away from sensitive structures, such as power plants, communication towers, and airports. This can prevent damage and disruption caused by direct lightning strikes. They can also be used to test the effectiveness of lightning protection systems, such as lightning rods and surge arresters. By subjecting these systems to controlled lightning strikes, engineers can evaluate their performance and identify areas for improvement. The study of lightning is crucial for understanding atmospheric processes and mitigating its dangers. Lightning is a major cause of wildfires, power outages, and property damage. It also poses a significant threat to human life. By studying lightning, scientists can learn how to better predict and prevent these hazards. Rocket-initiated lightning strikes represent a significant advancement in lightning research and protection. They provide a safe and controlled way to study lightning and to develop new technologies for mitigating its risks. They continue to be used in ongoing research to further enhance our understanding of this powerful natural phenomenon. The rockets used in these experiments are typically small, solid-fuel rockets. They are designed to reach altitudes of several hundred meters to several kilometers, depending on the specific research objectives. The conductive cable is usually made of thin copper wire, which is strong and has good electrical conductivity. The cable is typically grounded at the launch site to provide a reference point for the electrical discharge. The launch of the rocket is carefully timed to coincide with the presence of a storm cloud overhead. Researchers use weather radar and other instruments to monitor the development of thunderstorms and to identify clouds that are likely to produce lightning. The rocket is launched when the electrical field within the cloud is sufficiently strong, but before a natural lightning strike occurs. The data collected during rocket-initiated lightning strikes is analyzed using a variety of techniques. Researchers use sensors to measure the electrical current voltage and electromagnetic fields associated with the lightning strike. They also use high-speed cameras to capture images of the lightning channel and its propagation. This data is used to create computer models of lightning and to test theories about how lightning forms and propagates. Rocket-initiated lightning strikes are a complex and challenging experiment. They require careful planning, execution, and analysis. However, the results of these experiments have significantly advanced our understanding of lightning and its effects. They have also led to the development of new technologies for protecting people and property from lightning damage. Furthermore, the ethical considerations surrounding rocket-initiated lightning strikes are important. Researchers must carefully consider the potential risks to people and property before conducting these experiments. They must also obtain the necessary permits and approvals from regulatory agencies. The benefits of rocket-initiated lightning strikes must be weighed against the potential risks. While these experiments can provide valuable information about lightning, they also have the potential to cause damage or injury. Researchers must take all necessary precautions to minimize these risks. This includes conducting thorough safety assessments, using appropriate equipment, and training personnel. The public perception of rocket-initiated lightning strikes is also a factor. Some people may be concerned about the safety of these experiments, or about their potential impact on the environment. Researchers must be transparent about their work and engage with the public to address any concerns. Rocket-initiated lightning strikes are a valuable tool for scientific research and lightning protection, but they must be conducted responsibly and ethically. The future of rocket-initiated lightning strike research is promising. As technology advances, researchers will be able to conduct more sophisticated experiments and collect more detailed data. This will lead to a deeper understanding of lightning and its effects, and to the development of even more effective methods of protecting people and property from lightning damage. One area of research is focused on developing more accurate models of lightning. These models can be used to predict where and when lightning strikes are likely to occur, and to assess the effectiveness of lightning protection systems. Another area of research is focused on developing new technologies for preventing lightning strikes. These technologies include lasers that can be used to dissipate electrical charges in storm clouds, and conductive materials that can be used to create artificial lightning rods. Rocket-initiated lightning strikes are also being used to study the effects of lightning on the atmosphere. Lightning produces a variety of chemical compounds that can affect air quality and climate. By studying these compounds, researchers can gain a better understanding of the role of lightning in the Earth's atmosphere. The technology behind rocket-initiated lightning strikes is constantly evolving. New types of rockets, cables, and sensors are being developed to improve the accuracy and efficiency of these experiments. The use of drones is also being explored as a way to deploy conductive cables into storm clouds. Rocket-initiated lightning strikes are a testament to human ingenuity and our desire to understand the natural world. They represent a unique combination of science, engineering, and technology. By continuing to study lightning, we can learn how to better protect ourselves from its dangers and to harness its power for the benefit of society. The altitude of the rocket launch is a crucial factor in the success of the experiment. The rocket must reach an altitude where the electrical field is strong enough to initiate a lightning strike, but not so high that it escapes the cloud altogether. The optimal altitude depends on several factors, including the size and intensity of the storm cloud, the conductivity of the cable, and the electrical properties of the air. The timing of the rocket launch is also critical. The rocket must be launched at a time when the electrical field is increasing rapidly, but before a natural lightning strike occurs. This requires careful monitoring of the storm cloud using weather radar and other instruments. The angle of the rocket launch can also affect the trajectory of the cable. The rocket is typically launched vertically, but it can also be launched at an angle to target a specific area of the cloud. The conductive cable must be strong enough to withstand the forces exerted on it by the rocket and the wind. It must also be flexible enough to deploy smoothly without tangling or breaking. The material of the cable must be chosen carefully to ensure good electrical conductivity and resistance to corrosion. The grounding system at the launch site is essential for providing a safe path for the electrical current to flow to the ground. The grounding system must be properly designed and installed to minimize the risk of electrical shock. The sensors used to measure the electrical current, voltage, and electromagnetic fields must be calibrated accurately to ensure reliable data. The high-speed cameras must be positioned carefully to capture clear images of the lightning channel. The computer models used to analyze the data must be validated to ensure that they accurately represent the physical processes involved in lightning. The safety protocols for rocket-initiated lightning strikes must be strictly followed to minimize the risk of accidents. These protocols include establishing a safety zone around the launch site, using trained personnel, and monitoring the weather conditions. The environmental impact of rocket-initiated lightning strikes must be considered. The rockets produce exhaust gases that can contribute to air pollution. The conductive cables can also pose a hazard to wildlife. Researchers must take steps to minimize these impacts. The public outreach efforts are important for educating the public about rocket-initiated lightning strikes and addressing any concerns. These efforts can include providing information on the project website, giving presentations to community groups, and answering questions from the media. The collaboration between scientists, engineers, and technicians is essential for the success of rocket-initiated lightning strike experiments. This collaboration requires clear communication, mutual respect, and a shared commitment to safety. The long-term benefits of rocket-initiated lightning strike research are significant. This research can lead to improved methods of predicting and preventing lightning strikes, better protection for people and property, and a deeper understanding of the Earth's atmosphere.